All right, so today we are going to start into chapter 5, which is on the integumentary system, which is basically skin. And we are going to walk through all the things that are listed here for your skin. So we're going to talk about what are all the functions of your skin. And these are things that you may not realize your skin is doing. So we have a lot of functions that we'll walk through. And then when we use the term skin, we're actually talking about an organ that's on the surface of your body, and it has 3 very different layers to it. So the very top layer is called the epidermis. The epidermis is made of epithelial tissue. So remember when we talked about epithelial tissue in the last chapter, I told you that it has no blood supply, but it's very vascular, but it's very innervative. It has a great nerve supply. So your epidermis is made of epithelium. So that's on the very surface. Just under that, we have our dermis. The dermis is made of connective tissue. And then just under that, we have the hypodermis. And the hypodermis is made of fat. So we're going to walk through each of those 3 layers. We'll talk about the tissues in there. We'll talk about some of the different kinds of cells and some of the characteristics that we find. I think it's easy to remember the 3 layers, right? Because epi means above or on top. So the epidermis is sitting on top. Then there's the dermis, and then the hypodermis, right? Y'all should know what hypo means. Remember in chapter 1, we talked about our abdominopelvic regions and how we have the hypochondriac region, which means below the cartilage. So hypo just means below the dermis, hypodermis. We will also talk a little bit about skin color. So what gives your skin its color or its tone? Now we're not going to go over all the pigments that we find, but I am going to mention the 3 most common pigments that really tend to give your skin a lot of color and tone. And then towards the end of the chapter, we'll also go through a couple of things, like we'll talk about some of the glands that are in your skin. We'll also talk about some disorders that can affect the glands, right? I mentioned to you in the last chapter how we have oil glands, and because of the type of gland that we have with an oil gland, it's a holocrine gland, where you've got the whole cell bursting. You got a lot of stuff coming out of the duct, that it's very easy for those to get clogged. So we'll talk about things like acne. We'll also talk about things like sebaceous cysts. So we'll talk about some issues or homeostatic imbalances with some of our glands. We'll also talk about hair and hair follicles. So I always think this part's kind of interesting. We'll talk about why, like, the hair on your head can get really long, but your eyebrows stay pretty short. We'll also talk about nails as well. And at the very end, we'll talk about skin cancers, different types of skin cancers. I think we all probably know someone who's had skin cancer, or maybe you've had it yourself. And so skin cancer is super common. We'll talk about that. And we'll also talk about burns, different kinds of burns, like 1st degree, 2nd degree, and 3rd degree. And I mentioned this in chapter 4, tissue repair. We didn't talk about it in chapter 4. I told you I kind of moved all of that into chapter 5, so we'll touch on that here. Okay, so that is what we're going to talk about in chapter 5. I mentioned that we're going to start with functions of our skin. So the reason that we say our skin is the integumentary system is the term integument means covering. And all of the functions that are listed here are functions that your skin provides. So we're going to go into detail for each one of these. Now the first one that's listed up here, protection. Your skin actually provides you with 3 forms of protection, right? So one form of protection is a chemical protection. So a chemical protection is that your skin is actually either secreting a chemical that's protective, or there's a chemical inside the skin that's protective. So the secretions, one of them is called the acid mantle. This one is just like what it sounds like it is. It is an acidic secretion. And it actually causes the pH on the surface of your skin to be low, right? An acid has a low pH. If we think of our pH scale, which runs from 0 to 14, right? 7's in the middle, that's neutral. An acid is on the low end of the scale, and a base is anything above 7. So an acid's below 7, a base is above 7. So the acid mantle has a low pH. It's secreted on the surface of your skin, so it's all over the surface. And this is actually super helpful. Bacteria, think about them, they're living organisms, and they're like little people. They thrive in a very particular environment, just like we do, right? We can't live in an environment that's super hot or super cold. Same thing with bacteria. If they're living on the surface of your body, there's a lot of things they prefer. They prefer a normal human body temperature of 98.6. They prefer a very neutral environment because the majority of our body inside is neutral. So by secreting an acid mantle, we're actually making this an inhospitable environment for a lot of bacteria. So it cuts down on the bacteria that would otherwise inhabit the surface of our skin. Another secretion are secretions that we term bactericidal substances. So that term bactericidal, right? I always think like suicidal. So bacteria and cidal, which is killing or deadly. So these are substances that kill bacteria. They're deadly to bacteria. And there's 2 of them that are secreted from your skin. One is called human defensin. This is a super cool chemical that gets released. It is not specific. So I'll write that over here. Not, here my pictures are in the way. There we go. Not specific. That's not how you spell specific, guys. I can't talk and write at the same time. I struggle with that. All right. This one's not specific, meaning that it is not targeting any particular bacteria. It's just anything that doesn't belong. What it does is it punches holes in the plasma membrane of that bacterial cell, and it causes it to burst. It causes water to rush into the cell, and it bursts open. So it causes the cell to lyse open. Another one is called cathelicidins. Now these are specific, and notice that I have right here what they're preventing. They're preventing streptococcal infections from growing on the surface of your skin. So a lot of these secretions are things that we're going to talk way more about in Anatomy 2 when we do the immune system, because your skin truly is your first line of defense from things getting into your body. So having this acid mantle, secreting human defensins, secreting cathelicidins, these are all things that are keeping infections at bay on the surface of your body, which also means that it's going to keep things from getting into your body. Now another one is, another chemical protection is melanin. Melanin is a pigment that actually protects against UV rays. And I'm going to open up a little whiteboard up here so I can draw. And so typically what will happen, can you all see my whiteboard?
Yeah.
Okay, great. So typically what happens, if we think about just the cells in our body, right? They have a nucleus, okay? And our skin cells also have little vesicles in them filled with melanin. Melanin is a pigment. It's typically a dark pigment. And so we have these little melanin vesicles kind of all over the cells. And what happens is when you are out in the sun and the UV rays hit your skin cells, the melanin vesicles will migrate to the sunny side of the nucleus. So they'll migrate like this. And they basically form a little umbrella on top of the nucleus. And what they're doing is they're shielding the nucleus from UV rays. And so when the UV rays hit the nucleus, they bounce back off. Or when they hit that melanin umbrella, they bounce back off. So it's a great way for your body to protect your skin cells from UV rays. We know that all forms of radiation damage living tissues. So if UV rays hit the DNA, inside your nucleus is DNA. If the UV rays hit the DNA, it causes the DNA to mutate. I want you to think of DNA as sort of like the instruction manual for your cells. It tells your cells everything they need to know, how often to divide, what kind of proteins to make. And so if the instruction manual gets rewritten, if UV rays change the DNA, change the instruction manual, it can cause the cells to divide too fast. And that is what leads to things like tumors and cancer. And so by having melanin in there, which migrates to the sunny side of the nucleus and shields your nucleus from UV rays, you're protecting your DNA from getting rewritten. So it's a pretty cool thing that we have in our skin. Now, melanin is a dark color. So this is why when you go out in the sun and you are not wearing sunscreen, this is why you get a tan. Because your body not only makes more melanin so you can protect against UV rays, but that melanin is moving to the surface of all of your cells. So it's going to make you appear darker in color. Okay, so that's how we get that suntan. All right. Oops, I didn't mean to stop sharing my PowerPoint. There we go. Another kind of protection other than chemical is a physical protection. So your skin is a great physical barrier, right? It's continuous all over the outside of your body. And so it has continuity. In fact, if your skin gets cut, it heals super fast. And even if you have a deep wound or a deep cut, your body will create a scab on top of it, which is essentially like a human Band-Aid. So even before it's healed, your body is still trying to make this physical barrier continuous by creating a scab. So you have this nice continuous barrier. The other thing is that your skin is waterproof. So that means that, you know, when you take a bath, if you're sitting in the water, you're swimming in a pool, water is not moving through your skin. Your skin has a lipid coating in it, which is waterproof. And that's important because if you sat in a bathtub or you went to a swimming pool, if your skin weren't waterproof, you would absorb all that water and you would get huge and puffy, and it wouldn't be good for anybody. Now, I will tell you that this waterproof coating in our skin is not foolproof. There are some things that can get through the waterproof coating. Obviously, gases like oxygen and CO2, those can move back and forth across our skin. Now, this is not how we're getting oxygen into our bloodstream, but you can move gases back and forth. Other things that can make it through that waterproof coating are things like poison ivy oil. This is why when you brush against poison ivy or poison oak or sumac, you get those blisters because it's made it through that waterproof coating. Organic solvents, this would be things like acetone, right? We all know what acetone is in, ladies, fingernail polish remover. You ever notice that if you use pure acetone to remove your fingernail polish, your cuticles will get really dry? The reason is because acetone dissolves that waterproof coating. It dissolves the lipids that are in your skin. And so that's why your cuticles will get real dry when you use an acetone nail polish. You're just dissolving the fats that are in your skin. Heavy metals like arsenic, those can make it through your skin. And then even some drugs can go through your skin, right? There are some drugs that can do that. And so this is how we can have drug patches, right? So for example, there's a birth control patch that women can put on their hip and wear for a month, and the progesterone and the estrogen can go right through that waterproof coating into the body. So there are some patches that work that way by allowing drugs through. So you do have continuous barrier. It is waterproof, but I do want you to know that waterproof coating is just not foolproof. We also have our last kind of protection is a biological protection. The word biological means living. So we have a living component inside of our skin, the cells, that are very protective. So the cells that are protective are Langerhans cells. These are similar to white blood cells. Lymphocytes are white blood cells. I'll write WBC up here. And their job is to respond to a foreign antigen. So let me explain what this means. We have on the surface of all of our cells, we have a sugar coating. We call this a self-antigen. And this is how your body recognizes what belongs, is if that sugar coating is a self-sugar coating. All of your cells look the same. Now, we all have different self-antigens. Like mine are going to look different from Andrea's and different from Jason's. They're all different, right? And so this is why if, let's say, I needed a kidney and Jason was a pretty good match and gave me a kidney, it's not going to be an exact match to my self-antigens. So I might recognize it as foreign and try to fight it off. So this is how people can reject transplants, right? And so your lymphocytes, these white blood cells, they're going to respond to any sugar coating, any antigen that's foreign, that doesn't belong. And so that's really important to have right in our skin. We have this great barrier right here. And so you want some protective white blood cells in here so that if something were to make it through your skin, they're going to recognize it as foreign and they're going to fight it off. And we'll talk way more about foreign antigens and anatomy too when we do the immune system. Another kind of cell are macrophages. We say these are your second line of defense. So what that means is that, let's say you get a cut and a foreign antigen, like a bacterial cell, is able to make it through your skin and avoid Langerhans cells. That's your first line of defense. Well, thankfully, we have a second line of defense, and those are macrophages. Macrophages are these incredibly voracious phagocytic cells. They gobble up foreign organisms. And so they are our second line of defense. So if something makes it past your Langerhans cells, you have macrophages to try to fight them off. So these are great protective mechanisms in our skin, protecting us from getting sick. And then lastly, we have DNA. Now I know this one's gonna sound weird because I just told you that when UV rays hit your DNA, they can rewrite the instruction manual. But DNA also has the ability to absorb UV rays and dissipate those rays as heat. Now, that's not to say that the DNA can't get mutated. It can, but it can also bring it in, absorb it, dissipate it out as heat. By doing this, cells on the surface of your skin are actually protecting the cells in the underlying layers. So that means that, you know, if you don't have enough melanin, or maybe your melanin is really light in color, like my melanin is really light in color, then you're not as protected. And so that DNA will absorb the UV rays, dissipate it as heat, and protect the underlying cells from having damage. Okay, so those are all some biological protections. So those are our three kinds of protections, right? We have chemical, we have physical, and we have biological. Now, another big function of our skin is that it can regulate your temperature. And it does this by constricting or dilating the blood vessels in your skin. So when it's really hot outside, your blood vessels will dilate. Whoops, I don't know why that happens. So when a vessel dilates, it means it gets nice and big. And so when the blood vessels on the surface of your skin dilate, a lot of times your skin will get warm to the touch. It'll also get flush, right? Like your cheeks would get flush and get more red because you're pumping more blood to the surface of your skin. And you're doing this to help evaporatively cool your body, right? You're also sweating, so your skin is sweating to help cool you off as well. Now the opposite happens when it's cold. When it's cold, your vessels in your skin will constrict. So that means they're going to get really small and narrow. And what you're doing is you're shunting the blood away from the surface of your body and keeping it in your core, like in your body's trunk, so that you can keep your vital organs at body temperature. So this is why when it's really cold outside, the first things in your body to get cold, or even if it's super cold to get frostbite, would be fingers, toes, Your nose a lot of times gets really cold, and so do your ears. So it's all of your extremities that would get super cold, and that's just because you've constricted all those vessels and you're keeping your warm blood in your core, not your extremities. Another big function of your skin is sensation. So you have a lot of receptors in your skin that pick up different senses and different stimuli. And we call these exteroceptors. So that just means external receptor. It's going to pick up an external stimulus. So we have a couple that are listed here that we find in the skin. One is called a Meissner's corpuscle. A Meissner's corpuscle, where we find it, is very close to the surface of your skin. So it's going to pick up things like light touch or light pressure. We also have Merkel discs. Merkel discs, these are also going to help pick up light touch, light pressure. A lot of times these are associated with a deeper nerve, so they're making sure that the nerve stays healthy. A Pacinian receptor. These are located much deeper in your skin. So for these to pick up touch, it would have to be a harder touch. It would have to be deeper pressure for them to pick that up. So these are going to pick up, I always remember Pacinian starts with P, so I remember pressure. So these pick up more severe pressure. You also have some receptors that wrap around your hair follicles so that when your hair moves, you recognize that. So this is how you're going to pick up things like wind. Wind usually does not have enough pressure to activate a Meissner's corpuscle or a Pacinian receptor, but it causes your hair to blow. It causes the hair on your arms to move or the hair on your legs. So this is going to pick up wind. It is also going to pick up pests. So, you know, there are times where I might feel my hair move, right? Like maybe the hair on my arm, and I'll go like that if I'm outside because it's probably a mosquito, right? Mosquitoes are so light that they're not going to activate any of those light touch receptors, but they will cause the hair to bend and move, and you'll pick them up that way. So maybe spiders or mosquitoes or gnats, that's how you're identifying those on your body. So wind and pests. And then bare nerve endings. These are going to pick up pain. Okay, so these are some different receptors that will pick up different kinds of sensation in your skin. Another big function of your skin is that it has a metabolic function. Remember, your metabolism are reactions that are happening inside your body. So there are reactions that are happening in your skin. I write reaction like that just for short, reaction. Some reactions that are happening in your skin. The first one, making vitamin D, right? Your skin makes vitamin D. What do you have to have for your skin to make vitamin D?
Sun.
You gotta have the sun, right? So you have to be exposed to sun for your skin to make vitamin D. So I'm gonna do it like this. You gotta have sun for your skin to make vitamin D. And then what do you need vitamin D for?
Calcium.
Yes, you need it for calcium absorption. So there used to be a commercial for a calcium supplement which showed like a key with a D at the end. And so they would always say that vitamin D unlocks your calcium. And I love that commercial. I love that imagery because that is absolutely true. Most of the time, if you're taking a calcium supplement, what you're going to notice is that that supplement has not only calcium, but also vitamin D in it. Because honestly, you can't absorb calcium if you don't have vitamin D. So people who are shut-ins, people that never go outside, that never see the sun, they can develop a condition, an imbalance, where their bones become really soft and weak. This is a condition called osteomalacia. You don't have to remember this now. We're going to talk about it later on in the semester when we do bones. But that's a great example. If you don't see the sun, then you're not making vitamin D, and you're not able to absorb calcium. And calcium, we know, helps to make our bones hard. It's one of the things that it does. So your skin makes vitamin D. In fact, we all wear sunscreen. Hopefully we all wear sunscreen. It's important to do that. But what a lot of research has shown is that I have light eyes. So a lot of times if I'm outside, I have on sunglasses. And what a lot of research has shown is that how your body knows you're being exposed to the sun is through your eyes. And so they say if you are always wearing sunglasses when you're outside, you may not be producing enough vitamin D because your eyes aren't telling your brain that you are being exposed to sunlight. So it is important to take your sunglasses off, not for long, but just for, all you need is like 5 minutes a day. That's it. So it's not a ton. I'm not telling you to go outside with baby oil on and hang out in the sun, get a suntan. It's just walking to and from your car, walking to your mailbox. Those are things that would provide you with enough vitamin D. Another metabolic function of your skin is that it can activate some hormones, things like hydrocortisone. And then also it can make proteins like collagen or collagenase. And we know collagen is that really tough protective fiber that's really, really strong. So all of these things are made by the skin. And then one of the last, well, not the last, but one of the last functions of your skin is that it's a blood reservoir. Right? Think of the term reservoir. Right? A reservoir would be like holding water. Well, your skin is holding blood. Your skin can hold up to 5% of your body's blood volume. So we have about 5 liters of blood in our body, and our skin can hold about 5% of that. And what's going to happen is if another area of our body needs blood, our vessels will constrict and get small and shunt that blood where it needs to go, somewhere else. So the vessels in your skin get really small so that the blood can travel somewhere else in your body where it's needed. All right, and then I think this is one of the last ones. This is excretion. So you are actually excreting things from your skin, not in the way that you think of when you think of the word excretion, but there are things coming out of your skin. Nitrogenous waste. This is the same stuff that you find in urine. So like urea, there is a little urea that comes out from your skin. It's coming out from your sweat glands. Obviously, other things that are coming out from sweat glands are things like water and salt, right? Sweat tastes salty. Other things that you might excrete would just be byproducts that your body doesn't need, right? Someone who eats a lot of garlic, a lot of times their skin might smell kind of garlicky, and that's just that byproduct of what they're consuming. Alcohol. I used to have, she's passed away, but I had an aunt that was an alcoholic and she drank all the time. And even if I would see her and she would be sober, she would smell like alcohol because it's coming out from your skin, right? So your skin does excrete. So those are our big functions of skin. Are y'all okay with all those functions? Can you think of any questions? Okay, so we're going to walk through this next part. It's just the layers of our skin. So we're going to walk through the 3 layers of skin. Now I will tell you that your skin is different in different areas of your body. So there are some areas of your body where your skin is really thick. It's like 4 millimeters thick. And then there are other areas of your body where your skin is really thin, maybe only 1 millimeter, 1.5 millimeter thick. Can you think of somewhere in your body where your skin is super thick? It's going to be somewhere where you need a lot of protection.
On your feet?
Yeah, so the soles of your feet and then palms of your hand, right? I remember as a kid, my brother used to like stick needle, like pins through his palms. I don't know. He was weird. He still is weird. um, but yeah, palms and soles of the feet, right? You have really thick skin in those areas because you think about how much friction these areas are generating all the time with what you're touching and walking on substances. Thin skin. Can you think of somewhere where your skin is really thin? Like if it gets dry or cracked, it might bleed. Your lips, right? So lips have very thin skin. Your eyelids also have very thin skin, okay? So depending on where you are in your body, your skin's gonna range in thickness and it's gonna look a lot different. Now there's 3 regions to your skin, whether it's thin skin or thick skin. It always has these 3 regions, right? We have our epidermis. Now remember I told you when we started, epi means above or on top, right? So this is on the very surface, is what you can see. And remember, this is made of epithelial tissue. So that's easy to remember, epidermis, epithelial. Remember, epithelial tissue has no blood supply. So remember, A means not vascular. So there's no blood supply. So this is how you can get a paper cut, and it can hurt a lot, but it's not going to bleed, right? Just under that, we have our dermis. The dermis makes up the bulk of your skin. This is a really thick layer in your skin. It is made of connective tissue, so it's very tough, and it's vascular. It has a fabulous blood supply. It has to have a blood supply. And the reason it has to have a blood supply is because the epidermis doesn't. Now remember, cells are living things. They have to get nutrients. So how your epidermis gets nutrients is through diffusion. So nutrients actually diffuse up from the dermis into the epidermis. And then under the dermis is the hypodermis. Remember, hypo means below. And the hypodermis is under the dermis. It is made of, I'll write it over here, it's made of adipose tissue. So it is made of fat. Serves a lot of functions, same functions that fat does. So it insulates, it cushions, it protects. Now, a lot of times we'll call the hypodermis, we have different names for it. One term is called the superficial fascia. So the reason we call it that is because if you think about your skin, right? If you were to go take your skin off, right under your skin would be your muscle, okay? And what sits on top of your muscle is this connective tissue. It's really thin, called fascia. You've probably seen it if you have ever cooked chicken breasts. If you've ever gotten a raw chicken breast, you know that sometimes you can pull that clear film off the surface of it. That's fascia. It sits on top of muscles. And so the reason we call the hypodermis the superficial fascia is because it sits on top of the fascia of your muscle. Okay, so that's another term for it. And then one other term that we can give the hypodermis, there's actually 3 names. We can also call it the subcutaneous fat. Sub means under, cutaneous means skin. Now, a lot of times, textbooks do not consider the hypodermis as part of the skin. The skin is the epidermis and the dermis. And then they say that the hypodermis is just subcutaneous fat. It's just a layer of fat under the skin. Now, your book sort of classifies all 3 layers in the skin, okay, in the integument system. So this is a great picture of your skin, very similar to this. So you can see in brown at the very top, that's our epidermis. Okay, that's made of epithelial tissue. It's lots of cells in there, so you can see all those little tiny cells. Then you can see this big layer in the middle, right in here, and that's all that pink layer. That's our dermis. And the dermis is the thickest layer, but you're going to notice here that it has a lot of structures in it. You can see all the blood vessels, you can see hair follicles, you can see glands in there. And then at the very bottom is our hypodermis, and you can see that as fat tissue. Anytime in your textbook that you see yellow, a lot of times that yellow is indicative of fat. Okay, same thing with models. A lot of times on the models that we'll use and images that I use in your lab, if it's yellow, it's probably fat. So this is an image of your skin, a microscopic image of the skin, which you're also going to look at in lab this week. And you can see the same 3 layers. So you can see at the very top, it's usually very dark, is our epidermis. Okay, this thicker layer right in here, that's our dermis. And then at the very bottom, and again, if you look right in here, that looks just like our fat tissue. That's our hypodermis. So we're going to go through all 3 layers, and I'm going to talk about the kinds of cells and the kinds of tissues that you're going to find in those 3 layers, okay? So we're going to start in the epidermis, and I'm going to walk you through the cell types in the epidermis, and I'm also going to talk about the layers of the epidermis, okay? So remember, again, the kind of tissue in epidermis is epithelium. Now, specifically, what kind of epithelium? Remember, we have 2 kinds, simple and stratified. The function of a simple epithelium is absorption, secretion, filtration. Function of a stratified epithelium is protection. So what's in your skin? The one that's protective, right? Stratified epithelium, it's a stratified squamous epithelium. More than that, it's keratinized. Keratin is that waterproof protein. Sorry, I don't know why it's connecting all those lines together. And so we're going to talk about keratin a little bit later, okay? Now the types of cells. One kind of cell, keratinocyte. Another is melanocyte. Merkel cells, which I mentioned, and Langerhans cells, which I've already mentioned. We're going to go through each of those. I'll show you where they're found in the epidermis. And then the layers of the epidermis. It says right here, 4 or 5 layers. That depends on whether you have thin skin, which would have 4 layers, or thick skin, which would have 5 layers, okay? So our layers are listed there. I'm going to go over those with you as well. So we're going to start with our cell types, right? We have 4 kinds of cells. The first one, keratinocytes. These actually are the majority of your epidermis. I'm going to start this because you're going to see a question about that on your exam this week. Okay, what is the main type of cell found in the epidermis? It's keratinocytes. And if we think about the name, right, we know cyte means cell. These are cells that make keratin, right? And keratin is that hard, protective, waterproof protein. All of these keratinocytes, they come from, I know we haven't done the layers of your epidermis yet, but they actually come from the very bottom layer of the epidermis. And this layer is called the stratum basale. We'll talk more about this one in a little bit. Stratum just means layer. And I always remember, I pronounce it basale, so I can remember to put the E at the end when I'm spelling it. Okay, some people call it stratum basal. I say stratum basale, bottom layer. And this is a layer in your epidermis where the cells are constantly going through mitosis. So they're creating new cells, and those new cells get pushed up. And that's why at the very surface of your skin, your cells are sloughing off. They're dead by the time they get up here. So your skin has a really high regeneration capacity because of the stratum basale, okay? Because it's constantly going through mitosis and it's pumping out and making a ton of keratinocytes. The dead keratinocytes, by the time they get to this top layer, they're sloughing off, right? And you notice it more when your skin is dry. Like if your skin's really dry, some people call it ashy, right? You might notice it. I remember as a kid, like I would write my name in my leg, in my dry skin on my leg. That's gross. I shouldn't tell you all that. You might see extra keratin being formed in places where you have constant friction. So places like your feet, the soles of your feet, right? Calluses, palms, calluses. If you have a really hard callus, the reason it's there is you've produced extra keratin in that spot. So that's why your skin feels harder right there. When I went to undergrad at Ohio State University. And when I was at Ohio State, I was on the crew team. I was a rower. And I remember how awful my hands were when I was a rower. I would have huge blisters and huge calluses all over my hands because of the constant friction from the oar. So this is a picture from your book that is showing you only the epidermis. Okay, so I'm going to click back here. So again, all we're looking at right now is this part right up here. Okay, so notice how, I'm going to erase what I just did. Notice how this very top epidermis, it kind of does this, and it has all these invaginations. We're going to talk about why that's important in a little bit. But if you go here to this picture, you can see we are zoomed in so much. You see that one of those invaginations just right there. Okay, all the rest of this in purple, that is all the epidermis. Now, that image on the left, that is a microscope slide. The image over here on the right, this is an artist rendering of that, and that's the image I'm going to use as I talk about the different cell types because it's easier to see them. So do y'all see on the right, all of those orange colored cells? Those are all keratinocytes. So you can see they make up the majority of the epidermis, right? It's mostly keratinocytes. Another kind of cell that we'll find in the epidermis is our melanocytes. Now again, cyte means cell. So melanocytes make melanin, right? Keratinocytes make keratin, melanocytes make melanin. Now I mentioned melanin already. Melanin is that protective pigment that gets released and helps to protect your cells from UV rays. So melanin is made by melanocytes, and a melanocyte is this gray one down here at the bottom. So notice we don't have a ton of them, but we do have some. That melanocyte will make melanin. It stores the melanin in little vesicles called melanosomes. Those melanosomes then get pushed out of the melanocyte and they get taken up by keratinocytes, right? So all these orange cells, if you look at them, you see how they have these little gray circles, these little tiny vesicles in them. Those are melanocytes. Those are melanosomes. So the melanocytes makes the melanin, puts it in a vesicle, and then lets keratinocytes take up the melanin. And so now these keratinocytes, which are making up the majority of your epidermis, are protected from UV rays. So remember, this is the pigment that when UV rays hit your skin cells, those little vesicles of melanin move to the sunny side of the nucleus and shade it out, create a little sunshade. Another kind of cell that we find in our skin are called Langerhans cells, and they are these purple guys over here. Langerhans cells are part of your immune system. These actually come from your bone marrow. They are white blood cells, and their job is to recognize a foreign antigen. If they see something foreign, they gobble it up. They also activate the immune system. So remember, I mentioned to you earlier that these are part of the first line of defense. So if a Langerhans cell sees a foreign organism coming into your skin and recognizes it as foreign, not only will it gobble it up, but it'll activate your immune system and tell your immune system, hey, there's an invader in here and you need to watch out and monitor the bloodstream and make sure that it doesn't get any further. Now, one thing that makes Langerhans cells so great in your skin is that they have these really long branchy processes that kind of snake in between all these keratinocytes. So that if you have something sort of moving in between your keratinocytes, a Langerhans cell will pick it up and gobble it up. They'll recognize it as foreign. And then the last kind of cell is called a Merkel cell. And that is this guy right here. Merkel cells are, they're going to pick up light touch, but notice that it is connecting to this yellow structure right here. That yellow structure is a nerve ending. So Merkel cells are always associated with nerve endings, and they're keeping the nerve nice and healthy. So they're picking up light touch, but they're also helping to make sure that nerve stays nice and healthy. All right. So those are the different kinds of cells in our epidermis. We also have the layers of the epidermis that I want to walk you through, okay? So the very bottom layer, I've mentioned this one, is this one cell layer thick right here. That's our bottom layer of the epidermis. That's called the stratum basale. It's the deepest layer. It is connecting to the dermis, right? This pink part poking out, that's the dermis down there. And it's basically just one cell layer thick. It has keratinocytes in it. It has melanocytes in it. It has Merkel cells in it. Now, I mentioned to you that this is the layer that is constantly going through mitosis. So sometimes you might find in your textbook, they'll call it the stratum germinativum, which literally translates into the germinating layer. So it's the layer that's constantly going through mitosis, rapid cell division. Now the next layer up, I'll circle that one, is this layer right in here. And this is called the stratum spinosum. So this one is a little bit thicker, okay? It's several cell layers thick. And I always remember spinosum and I think spiny. Sometimes we call this the prickly layer. Because what happens is when keratinocytes are made in this very bottom layer, the stratum basale, when they're brand new, they're like babies, right? Babies are big and plump and juicy, and they got the big cheeks and the big legs. Same thing with cells. When cells are brand new, they're big and plump and juicy. And as those new cells move up towards the surface, just like babies, as they start growing and getting longer, they thin out. Same thing happens with your cells. The cells start to actually thin down and get smaller. But all of the cells that are in your skin in the epidermis are connected to each other. So what happens is they start out big and plump, right? And as, I didn't really put that in the right spot, did I? They start out big and plump. And as they move towards the surface and they get smaller, they're still connected to each other. And so because they're still connected to each other, they end up looking a little more spiny at those connection points. Okay, so that's why we call this sometimes the prickly layer. We do find all those keratinocytes that are in the stratum spinosum. Remember, they've all taken up the melanosomes. They've taken up those vesicles, so they're nice and protected from UV rays. You also have Langerhans cells in this layer. The next layer is the stratum granulosum. Now you're going to notice in that layer right there, the cells, the keratinocytes, look different. A lot of times the keratinocytes are very flat, but they also look very grainy, and you should be able to see that. You can see all those little granules in there. The reason is that this layer, the stratum granulosum, is making keratohyalin and lamellated granules. These provide the waterproof coating in your skin. So remember, your epidermis does not have a blood supply. Notice that nowhere in here can you see a blood vessel, right? So remember, how's it getting nutrients to all these cells? Through diffusion, right? Nutrients are diffusing up from the dermis. And those nutrients can diffuse up until they hit this waterproof layer right here. Then they can't diffuse up anymore. So what happens is, even though you need this waterproof layer in your skin, it's really important to have it so that things can't get into your skin. It's actually preventing nutrients from getting up to the rest of your cells. So effectively, the stratum granulosum, by making this waterproof layer, it's kind of strangling itself. So these cells are starting to die. That's why they look grainy. As a cell dies and the organelles die, you get this grainy appearance. So that's why I remember stratum granulosum, grainy, looks very grainy in appearance. All the cells above the stratum granulosum, they're all dead. And you know they're dead because notice if you look up in here, you see no nuclei. Those cells have already the nuclei and all the organelles have disintegrated because they're not getting nutrients anymore. Now the stratum lucidum, this is only present in thick skin. Now, we don't see it in this artist rendering. Where we would find it would be right in here. Okay, this would be the stratum lucidum. It sits right on top of the granulosum. And I'll show you an image of it so you can see it. You'll see it in your lab manual as well. This one gives you sort of this transparent band. And I want you to think about if you look at your palms or if you look at the soles of your feet, a lot of times if you look at where you have a callus, notice how it looks kind of translucent in color. That's because you can see that stratum lucidum in there. Okay, so this is a great image where you can see this lucidum. On the left, we're looking at thin skin, okay, that does not have a stratum lucidum. On the right, we have thick skin that does have a stratum lucidum. Okay, so I'm going to use the one on the right. So we've got this first layer down at the very bottom, one cell layer thick, right? That's our stratum basale. All of this in here, that's all the stratum spinosum, where it looks spiny because the cells are shrinking down. That dark band is always the stratum granulosum. And now you can see right above that, you see that sort of pretty translucent band. That's the lucidum. Again, you're only going to find that in thick skin. If we look at the left, again, we still see the same layers, right? Stratum basale. All of this is the stratum spinosum. Again, you've got this dark band is the granulosum. Okay, the dark band is always the granulosum. All right, and then the last layer, the last one at the very, very top that I have not talked about yet, you can see on both of these is the stratum corneum. This is a very thick layer of your epidermis. I remember this one because I think corneum, cornflakes. And if you look at the image on the left of thin skin, it looks like cornflakes stacked up. This is the flaky layer. This is the layer that's going to flake off, right? This is all dead. And so this is the outermost layer of keratinized cells. So all of this is the stratum corneum. It makes up about 3/4 of the thickness of your epidermis. And it has a lot of functions. Because it's all dead, it's great at protection. It's got waterproof protein in there, so it is a waterproof coating. Protects from abrasion, wear and tear, chemical, biological assaults. So having this stratum corneum is so important. And the thicker it is, the more protective your skin is. All right, so that is our epidermis. So everything that we just talked about is just this tiny little layer at the very, very top. Okay, so all those cells, all those layers. So your epidermis has 4 or 5 layers depending on how thick your skin is. The next layer down, the dermis, is the thickest layer of your skin. Derma means skin. And this one's very different. Remember, epidermis has epithelial tissue. The dermis, this middle layer of your skin, is not epithelial tissue. It can't be. Epithelium does not have a blood supply. This is made of connective tissue, right? So the type of cells that we find in the dermis are fibroblasts. So that should tell you a lot. Remember, of all of our connective tissues proper, cartilage, bone, and blood. Fibroblasts are connective tissue proper, right? So we know, all right, in your dermis, this is a connective tissue proper. We have loose and dense. The other kind of cells that we find in the dermis are macrophages, mast cells, and white blood cells. So right there, that tells you the function of your dermis. It is there for immunity. It is there for protection. That's important because your skin's an organ and it covers the entire outside of your body. It is your first line of defense. So you want cells that are in there to help fight infections from getting deeper into your body. Now, your dermis is innervative. It does have nerves, and it also has to have a blood supply because remember, the epidermis doesn't. So nutrients are going to diffuse up into that epidermis from the dermis. Now, unlike the epidermis, which had 4 or 5 layers, the dermis only has 2. So that makes it a little bit easier. Okay, so we're going to go through those 2 layers, and we're also going to talk about the tissues in the dermis. So this is an image on the left of your skin, right? Everything in pink, that's all the dermis. Now your dermis has 2 layers, and those 2 layers have different tissues in them. So the layer at the very top up here, that layer is called the papillary layer. The layer deeper is called the reticular layer. Now the images on the right of the papillary and the reticular layer are scanning electron micrograph images. And you can see that the tissues in those layers are very different, okay? In the papillary layer, we have a loose connective tissue proper called areolar tissue. Has a lot of white blood cells in it. It's very loose, it's very spread out, so white blood cells can patrol the area. That should make sense that you have that way up here at the very top of the dermis, so that if an infection were to make it through the epidermis, now you've got some white blood cells and macrophages in that areolar tissue patrolling the area, keeping it safe. Deeper down in the dermis, you have a different tissue. Deeper down in this reticular layer, you have a dense connective tissue called dense irregular. Now, when you look at that, dense irregular, to me, it looks like if you've ever taken yarn off of if you've ever taken yarn and made a little yarn ball, that looks like a yarn ball to me. What you're looking at, remember, dense irregular has a lot of collagen fibers, which are stronger than steel, running in different directions. So it provides a lot of strength in different directions, right? So this is what you're going to find down in that reticular layer, something nice and strong, being able to withstand tension. So let's go through those 2 layers, right? We're going to start in the papillary layer. So that's this top layer up here. So that's where we're going to start. Again, this is made of areolar connective tissue. It's airy, it's spread out, it's a loose connective tissue. It has tons of blood vessels. That's important because it allows it to diffuse to the epidermis. And because it's loose, it has a lot of white blood cells in it, macrophages, mast cells that can patrol the area for bacterial infections. Now, another thing that I mentioned that I would talk about in a little bit is if you notice, when you look at this papillary layer, notice how like the bottom of the epidermis and the top of the dermis have all these little like ridges. You know, it's not like a nice clean border. It's sort of all these ridges and invaginations. And so those projections are called papillae. So this is why we call it the papillary layer, because it's where all these papillae, these invaginations are. And within all these little papillae, within these little grooves, we're going to find a lot of capillaries. So capillary loops, bringing that blood to the area, allowing it to diffuse to the epidermis. We're going to find Meissner's corpuscles, which help with touch receptors. We're also going to find a lot of free nerve endings. So this is important so that you're picking up sensation from your skin. Now, all these little papillae, these dermal papillae, these are also going to help in other ways. I'm going to go back to this picture. I want you to imagine that the papillary layer of your dermis and the epidermis, instead of having papillae, let's say it's nice and flat and they come together like this. If you were to put friction on your skin, those two layers would separate. But instead, the epidermis and the dermis at that papillary layer, they come together like this. So when you put friction on your skin, they actually hold together a lot better. And so you're going to have deeper papillae anywhere where you have more friction. So palms, soles of the feet. So these are responsible for providing you with friction ridges, your fingerprints, right? You find these friction ridges where you have a lot of friction, and they help to enhance your gripping ability, right? These are patterns that are genetically determined. We all have different fingerprints, okay? Just under the papillary layer is that much thicker reticular layer. So I'll go back to this picture. This layer in here, right, that's our reticular layer. That's made of that dense, irregular connective tissue. It makes up about 80% of the thickness of your dermis. I don't know why it does that. There we go. And remember, dense irregular has collagen fibers that are arranged in a hodgepodge so that you can withstand a lot of tension from different directions. So it gives the skin a lot of strength and a lot of resiliency. It protects from scrapes and penetrating wounds. It also helps to bind water, so it helps to make your skin moist. I notice that the older that I get, if I am dehydrated, I'll get much bigger sort of sags under my eyes, those bags that you get. And the more hydrated I am, those plump up a little bit more, so they're not quite as noticeable. So staying hydrated is really important for your skin and for the rest of your body. Now you also have elastic fibers in this dense, irregular connective tissue, which allows your skin to stretch a little bit. Now this is an image, I stole this one from Google because your textbook does not have an image that looks this good. So I love this picture. This is thin skin, right? You can tell because if you look here, right, we've got our stratum basale, right? This is all, everything above this line, that is all the epidermis, right? Stratum spinosum. You see that dark band in here? That is the stratum granulosum. And notice there's no lucidum in here. You go straight to the stratum corneum at the top. So this is thin skin. But I like this image most because of the dermis. If you look at the dermis, so everything below that little red line that I drew, notice right in here, so I'll draw a line, that everything all in here, this is all the papillary layer. And you can look at that layer and tell that that tissue in there is different from the tissue down here in the reticular layer. So again, remember, this is areolar. It's a loose connective tissue. It is great for having white blood cells being able to move around and patrol. Everything down in the reticular layer is dense, irregular connective tissue. Okay, you can see all those collagen fibers in a hodgepodge. Now, a couple things that I want to mention about our dermis are just a couple of imbalances. So one that I mentioned a little bit in chapter 4 is that that dense, irregular connective tissue is really strong and it's great at withstanding tension, but it is not foolproof. If you put too much tension on your skin too quickly, then it will tear. And you'll see it on the surface as those white silvery marks, which we call striae. You probably call them stretch marks, right? So pregnancy, growth spurts, weight gain, all of these things, if they happen fast, it can lead to stretch marks. Now, another imbalance I want to mention are blisters. So remember how when we look at this papillary layer and the epidermis, how they come together like this, right? Because you have these papilla, these invaginations. And I told you that that's really important that we have that because if your skin came together like this, right, if it were flat without those invaginations, if you put any tension on it, it's going to separate. right? Anytime you put too much friction on your epidermis and it causes it to move away from the dermis, you get a fluid-filled pocket in there called a blister. So that truly requires a lot of friction. So, you know, if you're not used to, I don't know, doing a lot of work like shoveling or raking, you know, and in the fall, all these leaves fall and you've got to rake up all the leaves and you spend all day doing it, you might end up with blisters on your hands because it's not something you're used to. You haven't built up calluses, right? You've put so much stress that you've separated your epidermis and dermis, okay? And you get that fluid in there. So that's what causes blisters. Now, the last layer of our skin that I'll walk you through is the hypodermis. Again, some books don't even consider this as part of your skin. They say it is subcutaneous, that it's under your skin. So that this is basically just, your skin is just the epidermis and the dermis. And this layer of fat down here is not really part of your skin. So your book classifies this layer as the hypodermis. So it is found beneath the dermis. And it's mostly adipose tissue, right? It's mostly fat. So it has all the same functions of fat. It is protective, it insulates, it absorbs shock, all of those things. This layer of fat in your hypodermis is very typical that this layer will increase when you gain weight. So typically when you gain weight, if you eat more calories than you burn throughout the day, your body's going to store it as fat. And typically you're going to store it as subcutaneous fat. Your book says that it depends on males and females as to where you put that fat. It says in females, typically thighs and breasts. In males, they kind of get that spare tire in the abdomen going on. All right. One of the last things that I'm going to walk you through this morning is just a little bit on your skin color. So what gives your skin its color? So we have gone through the functions of your skin. We have talked about all 3 layers of your skin. So this last little bit is just on color. So there are 3 pigments that I'm going to talk about that contribute to skin color. The first one is one I have already mentioned, and that is melanin. Remember, this is made by melanocytes. This is put in vesicles called melanosomes. This gets taken up by keratinocytes. It protects your cells from UV rays. Melanin also gives your skin a color, and melanin can range in color from person to person. So melanin can be yellow in color, very light in color, or it can go to a reddish brown to a black pigment. So Caucasian, if you are white, if you are Caucasian, your melanin is going to be lighter. It's going to be more of a yellow color. African Americans, your melanin is going to be much darker, more brown, more black. The darker your melanin, the more protection you have from UV rays. So this is why Caucasians have a much higher incidence of sun-linked skin cancer. It's because our melanin is not nearly as protective as opposed to someone who has a darker melanin, okay? It is responsible for things like little pigmented areas like moles and freckles. That's where you might have local accumulations of a whole bunch of melanin in one little area. Another color is called carotene. Think like beta carotene. So carotene is this yellow-orange pigment. And it is most obvious in palms and soles of the feet because your body will store it. This is the same thing. It's the same pigment that gives different vegetables an orange color. So think like sweet potatoes and squash. So when you eat foods that are rich in beta carotene, right, sweet potato, squash, carrots, anything that's orange in color, then you will accumulate more carotene in your body, which is an orange pigment. And so you might notice if you eat a lot of carrots, you might notice that your palms might have a little more orange tint to them. In fact, there are some studies that were done where they tested beauty, and they found that people, when they looked at images, they said that individuals who had more beta carotene, they didn't know this, but people who had more beta carotene, so they had a little more orange hue to them, were actually more beautiful. So if you want to be prettier, just eat more carrots, eat more sweet potatoes. I guess that'll work. But I know my son, when he was little, I used to make all his baby food. Which is actually pretty easy if you have the little contraption, you can just steam it and squash it and you're good to go. And so he loved sweet potatoes. That was his absolute favorite. So a lot of times I would add sweet potatoes to something else. And so he got sweet potatoes like every day. And at one point I looked at him and I was like, you're looking a little bit like a Oompa Loompa. I'm gonna have to cut out the sweet potatoes. So like I could tell like his palms were getting really orange. So you just have to be careful not to overdo the beta carotene. And then the last pigment is hemoglobin. Now you all should know what this is. I'm sure you've heard of hemoglobin before. Hemoglobin is that red pigment that we find in our red blood cells, makes our red blood cells red in color. This is also what is responsible for giving us sort of this flushed pink hue to our skin. And so the reason is because your skin gets a blood supply, right? So the more blood you have pumping to the surface of your skin, the more flushed or pink color you'll have. This is why people will pinch their cheeks, right? And try to get the blood in that area so that it looks like they have on blush. This obviously is going to be something that's more noticeable the more fair your skin is. So the more yellow or light your melanin is. People who have really fair skin, a lot of times their undertone of their skin is much more red. And that's just because we can see the hemoglobin easier. The darker your melanin is, the harder it is to see that hemoglobin underneath. Okay? So those are our 3 skin tones. And the very last thing I'll mention it goes along with skin tone. These are just some abnormal skin colors that we might find. So the first one I have listed up here is called cyanosis. This is when you do not have enough oxygen. And when you don't have enough oxygen, your red blood cells, that hemoglobin, goes from being a really nice bright red to being a little more purplish or dark blue in color. And so that obviously is going to make your skin go from looking nice and pink and rosy to being more blue in color, right? And that's just from lack of oxygen. So think about if somebody's not breathing, what color do their lips turn? They turn blue in color. Your lips are red in color because you have a lot of very superficial capillaries. So that red color in your lips, you're seeing the hemoglobin underneath. So if you aren't breathing and your blood changes color and gets more blue, you're going to notice it in your lips. Where we actually notice cyanosis is more often in the beds of our fingernails. So I remember as a kid when I would go to the pediatrician, they would always look at my fingernails. They would be looking at the bed of my nails, making sure that they were nice and pink. Pallor or blanching. This is a pale skin tone, and a lot of times this is from emotional stress or even low blood pressure. Right? When your blood pressure tanks, think of pressure as in think of like filling up a water balloon, right? The more water you put in it, the more pressure there is in there. So that's kind of how I equate blood pressure. If your blood pressure is low, you don't have enough pressure to push your blood out to the surface of your skin, so it doesn't look nice and rosy. You look really pale. You look really drawn, right? Emotional stress can also cause your blood pressure to go down, and that can also cause you to look really pale. Okay, so this is just that your face has drained of color, right? You've gotten some bad news and your face is drained of color. You've lost that blood pressure. If your blood pressure is always low, you might always look a little pale. Jaundice, this is a yellow skin tone. This is actually from a liver disorder. So your blood cells only live in your body for about 120 days, after which point they get taken out of circulation and broken down into pieces. Hemoglobin is one of those pieces that we have to break down. This is in your red blood cell. And as hemoglobin gets broken into its parts and pieces, one of its byproducts is called bilirubin. And you don't have to remember all of this, I'm just telling you. Bilirubin usually gets taken up by your liver and it comes out from your feces. Your liver takes up the bilirubin from your blood and excretes it in bile, and it comes out the other end. If your liver's not working, then it's not taking up that bilirubin, and bilirubin is hanging out in your body. Bilirubin has a yellow color to it, and so your skin tone will look more yellow. The whites of your eyes will get yellow. A lot of babies are born jaundiced. And this is just because their liver is very immature. They haven't been eating solid foods yet, so they're not having bowel movements yet to get rid of the bilirubin. So a lot of times if a baby is born jaundice and they have that yellow skin color, a lot of times they look like my son had a little jaundice. He looked sort of tan, oddly enough. And so his was not bad enough. His bilirubin count wasn't high enough to cause any concern. So they just said, make sure he's having dirty diapers and he'll be fine. And sure enough, a week later when they checked his bilirubin, it was down because his liver was processing, putting that bilirubin into his intestines, and he was pooping it out. If your bilirubin count is really elevated, a lot of times they might put babies under a billy lamp. It's where they put the little goggles on them, they put the UV lights on them, and it helps to break the bilirubin down faster. And then the last one is bruising. Bruising are those black and blue marks that you get in your skin. This is just because you've broken a blood vessel and your blood is clotting in that area. Okay. So those are just some abnormal skin colors that we find. And so we will pick up with the different appendages in your skin. We'll talk about skin cancer, and we'll go through burns as well on Wednesday.